Welcome, great achievers. In this video, we'll be looking at past questions on work, energy, and power. Check the description for the full video on work, energy, and power. So let's start. We are starting with question 11 of November WAEC 2000. And the question says, it said 11A, this one carry pikin. 11A says define work. AI says define work. And then AII says state the unit. And we all know that work is the product of the force and distance moved in the direction of force. Work is the product of force and distance moved in the direction of force. Remember, we said that when there is no distance, work has not been done. Work can be said to be done when the force has moved a distance. Now, the II says state the unit. Now, what is the unit? It's in joules or Newton meter. And then the question 2. No, not 2, 11B. 11B says the diagram below shows two forces F1 and F2 acting on an object A of mass 5 kilograms. So let us draw it. We put up the diagram. If this is the object A, this is the A, and the weight of this, the weight acts downwards is 5 kilograms. And then this is force F2 and this is force F1. So let me repeat the question again. It says the diagram below shows two forces F1 and F2 acting on an object A of mass 5 kilograms resting on a frictionless surface S. Before we answer this question, I would like us to demonstrate using this our toy. This is our toy. Let's now take it that this toy is the object A, and then here is our frictionless surface. When you talk about frictionless surface, it means it's a smooth surface. It's a surface with no resistance. It does not have any resistance. The object can easily slide over this surface. That is why it's called frictionless surface. Then the question now says, I of this question says, state the condition under which this object will remain at rest. State the condition under which this object will remain at rest. That's the I part of the B question. And then, so let's take this before we go to the II of the B question. Now, they say state the condition under which this object will remain at rest. So what condition? The condition is that the two forces F1 and F2 must be equal. Now I'm applying forces here with my right hand and my left hand on this lorry, and you know that it is not moving. You can see it's not moving. The forces I have applied are equal. So that is the only condition under which this lorry will remain like this without moving. But once one force is greater than the other, it will now move in the direction of that force. Now let me make my left hand force to be greater and see what will happen. You see it is now moving towards the direction of the greater force. So that's it. Now the second part of the question, BII, now is giving us, is asking us if F1 and F2 are 10 Newton and 18 Newton respectively. So if F1 is equal to 10 Newton and F2 is equal to 18 Newton. So here is 18 Newton force and here is 10 Newton force. The question says calculate the work done when the object moves through a distance of 2 meters. Calculate the work done when the object moves through a distance of 2 meters. Now we have our forces F1, F2, and then the distance is 2 meters. And then we are asked to calculate the work done. Remember, we go back. What is work done? Let's start here. Work done is equal to force times distance. Work done is equal to force times distance. And then we are given force. There's something is happening here. We have two forces. So what do? Remember, in resolution of vectors, when the forces are in opposite direction, as in this case, the two forces are in opposite direction. This is 18 Newton force and this is 10 Newton force. When the forces are in opposite direction, what do? We subtract. So we now have that 18 Newton minus 10 Newton. And this will give us 8 Newton. So we have here work done is equal to 8 Newton times 2 meters, which gives us what? 16 Newton meter, or 16 joules. That is our answer. Okay, the next question we'll be looking at is this. A box is pulled a distance S along a smooth horizontal floor by a force F of magnitude F inclined at an angle to the horizontal. The work done is, let me go through the question again. Actually, this question is 2005 NECO objective part of it. So the question says, a box is pulled. If we have this to represent our box, the box, let's use this to represent the box. A box is pulled. Look at it being pulled. See the pulling, see it moving. Look at it moving. It's pulled along a smooth horizontal floor. See our smooth horizontal floor. See our smooth horizontal floor. F of magnitude F, inclined at an angle. Look at this. As I pull it, it's moving, and this rope, this force, is inclined at this angle to the horizontal floor. All right? By a force F of magnitude F inclined at an angle theta to the horizontal. The work done is, I'll go through it straight now. A box is pulled a distance S along a smooth horizontal floor by a force F of magnitude F inclined at an angle theta to the horizontal. Full stop. The work done is, the options are A, F times distance cos theta, B, F times distance cosec theta, C, F times distance sec theta, and D, F times distance sin theta, E, F times distance tan theta. Now let me show you this way also. If this is inclined, this is the force, and then is inclined to the horizontal S, smooth surface S, at an angle theta. Remember, we said when the force in the resolution of vectors, when a force is pulling along the horizontal axis, we said that we have that the force along the horizontal axis is what? F of x cos theta. All right, that's the force along the horizontal axis. So from here we now have that the work done which is the force times distance. And then, and force here, work done is equal to F along that smooth surface times what? Distance times what? Cos theta. That is the answer. But if they had asked us the vertical force, look at it, look at the rope, the vertical force, the force pulling it up, the vertical force that will help this to offload the load. That is the vertical force. It will be force pulling in the pulling it in the vertical direction is F sine theta, and then force pulling it in the horizontal direction is F cos theta. So we go to the next question. Next question. The next question. Here we have the next question. It says a girl whose mass is 20 kilogram climbs up 25 steps, each of height 15 cm in 10 seconds. Calculate the power expended. Full stop. We are asked to take G to be equal to 10 meter per second squared. Let me take the question again. A girl whose mass is 20 kilogram climbs up 25 steps, each of height 15 cm in 10 seconds. Calculate the power expended. Take G to be equal to 10 meter per second squared. Let me divide this, and then let me now explain something. Remember when we treated the work, power, energy, work done, power, and then energy, we said that when the work done in climbing up the steps, you don't calculate the number of steps. Number of steps you don't calculate. We only calculate the height. So if this girl climbing up, if this girl is climbing up this, look at, let's see the steps, is climbing up 25 steps, 25, look at it, and then you have this girl climbing up this 25 steps. You don't calculate the number of steps. Our interest here is on the height, the total height. That is our interest. Our interest here is the total height, not the number of steps. And here, to confuse you, they now gave you the number of steps, and then they describe each of them is having 15, the height of each is 15 centimeters. So what you do is that, now look at it, this one, see the height, this is height, this is this height. So each of them, this is having 15 cm, this is 15 cm, this is 15 cm, and then this is having 15 cm up until 25. So we now calculate the total height, and we now have, so for this we have our solution. We now have the power. Power is equal to work done. Power is work done all over time taken. All right? And then work done. Work done is equal to what? mgh. All right? And then mass is given. The girl's mass is what? 20 kilogram. And then G is 10 meter per second squared. And then the height is 25 times 15 all over 100. We have to change 15 centimeter to meters, so it's now in meters. All right, so We have 25 times 15 over 100. Now, the power is equal to work done all over time. And then we have our parameters. Always bring out your parameters. When you bring out your parameters, you see that it will be easy for you to substitute. We have our parameters. What we are doing here now is just to substitute. Let us now substitute these parameters into the equation, into our known equation. We are working from known to unknown. The unknown thing is power. Every other thing here is known. So we now have our mass 20 kilogram times we have the G 10 meter per second squared. We have the height, which is 25 times 0.15 meters, all over 10 seconds. That is the time. When you calculate this, is going to give you 75 watts. That's our answer. Keep solving. Okay, now we're going to be taking questions from JAMB, past questions from JAMB. Now the first one is, how long will it take a 60 kilogram man to climb a height of 22 meters if he expended energy at the rate of 0.25 kilowatts, and you are giving G to be 10 meter per second squared? Actually, I wrote JAMB this 1998. 1998 JAMB questions. The options are 5.3 seconds, A, B, 34.5 seconds, C, 41.6 seconds, D, 52.8 seconds. Now we go to solution. And in solving this problem, you need to read meaning and then understand the question very well. They now said, how long? And when you hear how long, it is time it has taken. And then when you hear how far, it is distance. So please take note of them. So we have solution. The man's mass is 60 kilogram. The man's mass is 60 kilogram. We now have the height. The height is H is 22 meters, and then we are asked to take G to be 10 meter per second squared. Now the next thing is the energy expended, which is power. P, power, energy expended is 0.25 kilowatts. 0.25 kilowatts. Now the kilo must be changed to 1000. Kilo stands for 1000. So this is 0.25 times 1000 watts. That is what we have. And we go to look for what we are asked to calculate. How long? So we are calculating the time it has taken this man to climb this height. And we know that power is mgh all over time. That is, power is work done all over time. So this is work done all over time. Power is work done all over time. It is mgh over time. And then looking at this, we all have our parameters there. We have the mass is known, G is known, H is known, time is not known, but P is known. So we substitute. We now have make time the subject of the formula. When you make time the subject of the formula, it's now giving you mgh all over P. So time is our mass. Just substitute, very easy. 60 times 10 times 22 all over 0.25 times 1000. And this, when you calculate everything, it will give you 52 0.8 seconds. So the correct option here is option D. Option D is the correct option. So we go ahead, we solve again from 1999. The one we solved now was from 1988 JAMB question. The next one we are going to look at is 1999 JAMB question. Listen, JAMB questions, I think they love questions from work, energy, and power. It is plenty there, and they keep asking questions because students keep failing and they keep asking. So wake up, read, let's give them a challenge, and we answer their questions. Maybe they will cool down for us. So the next question is this: a car of mass 800 kilograms attains a speed of 25 meters per second. As I'm reading it out, let me be writing out the parameters so that we will not be taking time. So it said a car of mass 800 kilograms attains a speed of 25 meters per second in 20 seconds. So a car of mass, so we have mass of the car 800 kilograms attains a speed, and remember, speed, we can substitute speed with velocity. So it's either speed or velocity. So the speed is 25 meters per second, and then in 20 seconds. So time here, the time is 20 seconds. We are bringing out the parameters. That is what you always do. Then the power developed in the engine is power. Now they ask you power. We don't know the power developed in the engine. The power developed in the engine is, so you have options. A, 1.25 times 10 to power 4 watts. B, 2.50 times 10 to power 4 watts. C, 1.25 times 10 to power 6 watts. D, 2.50 times 10 to power 6 watts. And the question is JAMB 1999. So what do? We work from known to unknown. Let's go. Remember, the power is always work done all over time. Work done all over time. And work done is what? Force times distance all over time. Force times distance all over time. And remember, I said you work from known to unknown. We are to calculate power developed. And look at these equations. Now, power is not known. Here, the force. Here, force is unknown. All right? And then this is the distance. Do we see this? We have speed. We have time. This distance is unknown. And then only time is known. So here, in this equation, we are having 3 unknown. And we have to do something. We go further. We can say that P is equal to, we have that force times distance all over time. Remember, distance all over time, if we pull out distance all over time, this gives us velocity. All right? It gives us velocity. So we now have that power is equal to force times velocity. This is unknown. This is still unknown. And we now have velocity. Velocity is 25 meters per second. We go over to this side. Quickly. I hope you are enjoying this. Now, power is unknown, force is unknown. But from the parameters we have, we can calculate force. That force is equal to MA. All right? MA. Force is equal to MA. Now, it's getting interesting. This is unknown. This is known. This is unknown. We still go. A is equal to V all over time. Change in velocity over time. Acceleration is velocity all over time. And then velocity is known, time is known. We are getting closer. Velocity is what? 25 meter per second all over time. 20 seconds. So A is now, when you divide, you will have 1.25 meters per second squared. 1.25 meter per second squared. That is what we will have. We will now substitute it into our equation. Force is now equal to MA, which is the mass, which is 800 kilogram times 1.25 meter per second squared. And then we now carry this. When you do this, we are now getting 1000 newtons. That is what we get. When you do this, you get 1000 newtons, and we now take this force back to power. So power is equal to force times velocity. So power is equal to force 1000 newtons times velocity, which is 25 meters per second. And this will give us 2500 watts, because we already changed, or 25 kilowatts. So the option here, the correct option here is B. The correct option here is B, which is 2.50 times 10 to power 4 watts. That is the correct option here. Keep solving. It's interesting. Thank you.